Hey guys, so again it's Middle Shah, and as per my saying in previous session that we will start in next session one more new method. So to understand this method, first of all you have to it's need to necessary to understand some theory of this method. Okay, so in this session we are going through the theory of this particular method. So let's start with this theory, guys. And here I have written some examples, sorry, some definitions of the theory that first of all it's given simply connected and multiply connected regions, and that we will do for the simply multiply and for the independence path. Okay, so this below there is given two definitions. 1 minute I'm pointing out. Okay, this one Cauchy's integral theorem, and one more definition is given Cauchy-Goursat theorem. So these both definitions is most important because based on these definitions only we are going to solve its examples. Okay, so this concept is very much useful to understand for the examples, and the definition is given: if a function f of z is an analytic function and its derivative f dash z is continuous at each point inside. Okay, what is written? If a function f of z is analytic function, f of z हमें क्या चाहिए? Analytic function चाहिए. Now what is analytic? Okay, to check the analytic for some particular point in the denominator you have to check. Okay, suppose in the denominator it's given z minus 1. Suppose into the denominator अगर छेद में आपको ऐसा दिया है कि z minus 1, so in place of z if we will put 1, okay, then we can say that 1 is analytic function. Why? Because हम लोग अगर पुट कर रहे हैं 1 तो 1 minus 1 क्या होगा? 0. So उसका जो डिनोमिनेटर है, उसका जो छेद है वो क्या हो जाएगा? 0. Okay, so if it will be 0 then we can say that the given function is analytic for that particular point. Okay, so यहाँ पे हमें क्या चाहिए? f of z एनालिटिक चाहिए and its डेरिवेटिव, उसका डेरिवेटिव भी हमें फाइंड करना है f of z का, f dash z. Okay, and that will be continuous. Continuous it means we can say that the given function will be differentiable. अगर वो differentiable होगा तो वो क्या होगा? Continuous होगा ही. This one we have studied into the analytic function. Okay, into the first unit. So I hope guys you all know very well. So f dash z is continuous at each point inside and on a simple closed curve C. Then we can write integration over the C f of z dz equals to 0. So अगर ये दोनों condition satisfy हो रही है, then we can write I'm highlighting guys. Okay, then we can write the integration of f of z dz, that will be a 0. Directly you can write 0. Okay, and with same one more definition is given Cauchy यानी कि Cauchy-Goursat theorem और Cauchy-Goursat theorem. और यहाँ पे क्या है? If f of z is analytic at all points inside, अगर वो analytic है, that is at the all points of its inside region. Okay, and on a simple closed curve, अगर वो simple closed curve भी है यानी कि कोई boundary उसकी fix है, like mod z equals to given 2, right, mod z equals to 3, mod z equals to 1.5, तो वो fix हो गया है. ऐसा नहीं है कि mod z is less than 2 और mod z is greater than 3. Okay, so अगर आपकी boundary fix है like mod z equals to 2, then it contained in a simply connected domain D, then we can again write for that particular equation, for that particular function, that the integration f of z dz equals to 0. Okay, now next, examples are given that evaluate. First example is given: evaluate integration C e raised to z dz where C is mod z equals to 1. Okay guys, so first of all you have to write f of z and definitely it will be e raised to z. Okay, now next, अभी उसको क्या, उसका क्या फाइंड करना है आपको, उसका फर्स्ट डेरिवेटिव. आई थिंक आई फॉरगॉट हियर टू फाइंड इट्स फर्स्ट डेरिवेटिव, so I'm writing with the pencil. If it's possible, then f dash z, that will be same function only, e raised to z. I'm not writing properly, guys, I'm so sorry. Okay, but I hope you all understood that what is the first derivative of e raised to z. That will be same only, e raised to z only. ठीक है. So फर्स्ट ऑफ ऑल एफ ऑफ जेड फाइंड करना है, देन आफ्टर आपको फाइंड करना है एफ डैश जेड. ओके, सो उसका डेरिवेटिव भी वही होगा. नाउ सिंस एफ ऑफ जेड इज डिफरेंशिएबल, why it is differentiable? Because if you did if you could able to do first derivative, then definitely you can do second or third derivative, because you can see the function is given here e raised to z and it is unstoppable. You can derivatives this term continue in the continuation, right? So that's why we can say that the given function is differentiable. Okay, so definitely it is analytic inside and on C. सो इसीलिए वो एनालिटिक है, डिफरेंशिएबल है, इट मीन्स इट इज एनालिटिक. एंड दिस वन वी हैव स्टडीड इनटू एनालिटिक फंक्शन इन आवर फर्स्ट यूनिट. सो दोनों यहाँ पे सेटिस्फाई हो रहा है. सो डेफिनेटली एफ डैश इज ऑल्सो कंटिन्यूअस इनसाइड से. अगर एफ ऑफ जेड डिफरेंशिएबल है तो डेफिनेटली एफ डैश जेड भी क्या होगा, डिफरेंशिएबल. और अगर वो डिफरेंशिएबल है, इट मीन्स वी कैन से दैट इट विल बी कंटिन्यूअस. ओके, so this both conditions are going to satisfy. So that's why, so by Cauchy's integral theorem, we can write that integration f of z dz equals to 0. Okay, now next one is given. Okay, now see the second question is given. Evaluate integration e raised to z square dz where c is any closed counter, right? And justify your answer. Okay, so see guys, यहाँ पे अगर आपको दो एग्जांपल्स आ गए तो बाकी की सारी एग्जांपल्स में सेम ही मेथड है. ठीक है, so as you know that first of all you have to find f of z and then after you have to find f dash z. So f of z I have written here e raised to z square and the derivative of this function will be e raised to z square as it is. और अभी किसका रिमेनिंग है, z स्क्वायर का. ओके, सो जेड स्क्वायर का क्या होगा, 2z. सो वो मैंने यहाँ पे लिखा है. सो सिंस एफ ऑफ जेड इज डिफरेंशिएबल, व्हाई? बिकॉज सी यू कैन डू इट्स second derivative, third, fourth up to the so on. So you can find its whole the derivative, so that we can say that the given function is differentiable. Now if it is differentiable, then we can say that it is analytic. Okay, and if f of z is differentiable, then f dash will be differentiable, and if f dash z will be differentiable, then f dash z will be continuous. Okay, so by Cauchy's integral theorem we can write this one equals to 0, यानी कि f of z dz equals to 0. so सारे के सारे एग्जांपल्स में क्या करना है गाइस, हमें f of z फाइंड करना है, फिर f dash z फाइंड करना है. ठीक है, और दोनों अगर कंटिन्यूअस है, दोनों अगर डिफरेंशिएबल है, यानी कि अगर हम उनका डिफरेंशिएट बार बार उसको कर सकते हैं, आई मीन वी कैन, इफ वी कैन फाइंड इट सेकेंड, थर्ड और फोर्थ डिफरेंशिएशन इन दी कंटिन्यूअस वे, देन इट विल बी डिफरेंशिएबल. नाउ अगर वो डिफरेंशिएबल हुआ, देन वी कैन कॉल एज इट विल बी एनालिटिक फंक्शन. ओके, और अगर वो एनालिटिक डिफरेंशिएबल है, then we can write it will be continuous. Okay, so now in the all the examples you have to apply with the same procedure only. So here now it's given third example. If C is any simple closed counter, then either in either direction, then show that the exponential e raised to z cube dz equals to 0. Okay, so first of all you have to find f of z. So this one will be your f of z, right? So मैंने यहाँ पे लिखा है e raised to z cube. exp is nothing but the e raised to z cube. Okay, so this is your exponential only. Then you have to find its first derivative. So this one will be its first derivative, or this one is same like the second one example. अगर वो differentiable है, तो वो क्या है, कंटिन्यूअस भी है और एनालिटिक भी होगा. सो दैट्स व्हाई वी कैन राइट द इंटीग्रेशन ऑफ एफ ऑफ जेड dz will be 0. Okay, so now these all examples are similar to this 1 to 3rd example. So was you have to do with your own self, guys, and any kind of queries you can contact me anytime. So in this lecture we have studied what is Cauchy integral theorem. Okay, but यहाँ पे जो examples थे वो सारे के सारे ऐसे examples थे जिसमें यहाँ पे functions आपका analytic था. it means कि वो कोई भी point से कोई भी point पे वो analytic बन सकता है. Like अगर z की वैल्यू यहाँ पे कोई भी पुट करो 1 2 3 4 etc. okay, then it will be analytic, right? अगर वो डिनोमिनेटर में ऐसा होगा कि अगर कोई फंक्शन डिनोमिनेटर में दिया है z-1 के z-2 के फॉर्म में, तो पॉसिबल है कि वो एनालिटिक नहीं होगा. ओके, और ऐसे एग्जांपल्स हम लोग करने वाले इन आवर नेक्स्ट सेशन. ओके, सो टिल दैट प्लीज कैरी ऑन विथ दिस सेशन. For more examples we will go in our next session. Thank you guys.